Pyramids. Today's discussion is on pyramids. Pyramids are three-dimensional figures that start with a point and one polygon called the base. When you connect the point to each corner, you'll get a pyramid. So using a straight ruler, we will connect the point on the top directly to the vertices of the base. That base happens to be a square base. Here's another example. This is another kind of a pyramid. We're not going to be discussing oblique pyramids necessarily in this particular class, but it's nice to see. And this one would be a triangular prism. Okay. Lots of definitions in this section. So there's the base, which is the bottom. There's the lateral faces, which are the sides. The lateral edges, which are the edges of the sides. And the altitude, which is the segment drawn from the point P, the top, perpendicular to the bases or on its plane. So we'll make a nice fresh diagram and we'll define all these things. I'm going to leave out the two back ones because there's going to be a lot of lines. So, in a regular pyramid, the base is regular. So this would be a 1, 2, 3, 4, 5, 6. A regular hexagon would be the base. P is directly over the center of the base. What kind of faces? What shape are each of these faces? Well, they're triangles, and they're particularly isosceles triangles. They're isosceles triangles. The lateral edges of a regular pyramid are congruent. So a regular pyramid has three lengths. We're going to do hot pink here. The first is called the height, and that we use the letter H. So the height would be from the point on top, perpendicular, to the bottom. So that would be the height. We call that H. Too fancy. H. The height is perpendicular to the base. The length of a lateral edge, let's call this green. We call this the letter E. E, the length of a lateral edge. So E would be like here, E would be in front of us, and so forth. So E is called a lateral edge, edge beginning with an E. The slant height, which is the height of each of these triangles, we call the slant height L. The slant height is L. So what we have to do for the slant height of each of the triangles is get a straight ruler, and we want to go from the point perpendicular along one of those isosceles triangles. And that's what we call L. I could draw one of those straight in front, but it would be in the way of the H, which is in the middle of the diagram. So you guys get that? So the L could be right in the front here, but it would be covering the height of the pyramid that we just defined. So those are some definitions. In any pyramid, the volume turns out to be, our magic fraction is 1/3. It's 1/3 of the entire, if it was a prism, in other words, if we were to make this a prism, which would mean that there were two bases, it's 1/3 of a prism formula. So it's 1/3 of the base, capital B means the area of the base times the height. So we've already been talking about capital B, but capital B, where capital B stands for the area of the base. That's just what capital B stands for. Okay, turning the page, let's see if we can apply and look to see if we can find some things about a regular pyramid. The cool thing about a regular pyramid is that there are lots of right triangles involved. So the pyramid shown to the side is regular with a square base. The lateral edge is square root of 41. Draw in and find the slant height. Okay, so the slant height, again, is from the top point perpendicular to, it's really, the slant height is like one of the triangles on the side. Okay. So we have to find that slant height. Well, if this is an isosceles triangle, we know that this length has to be 4. So we can just use Pythagorean to find the slant height. So the slant height, which is called the letter L, isn't it? Yes, L. The slant height would be square root of 41 squared, which is the hypotenuse, minus 4 squared, which is one of the, so we're just using Pythagorean to find this blue length. And if you do that out, you get 25. But we have to take the square root of it to get our answer. So the answer is actually 5. Actually, L squared. Remember, A squared plus B squared equals C squared. So we have to get back to just the actual. Draw in and find the height of the pyramid. Okay, so to draw the height, we want to draw the perpendicular distance from the top to the middle. And I made that pink. And now we're going to know, we know this is going to be a right angle here. And we want to draw in and find the height of the pyramid. Okay, well now we know this thing is 5. We just figured that out. This thing is 5. The slant height is 5. This is what we don't know. But do we know from here to here? Well, if this whole side is 8, half of 8 is 4. So this, you can solve this. This is a 3, 4, 5 right triangle. 4 squared plus h squared is 5 squared. And it turns out that this is actually 3. The height of the pyramid is 3. Find the lateral area of the pyramid. Well, the lateral area, to find the lateral area, we'd have to find the area of each of these triangles. So, lateral area of this one that we can see here, well, the height is 5 and the base is 8. So it's 1/2 base times height. So that would give us 4 times 5 is 20. But we have 4 of them. So the entire lateral area would be 20 times 4, which is 80. The total surface area of the pyramid would be equal to the lateral area plus the area of the base. Well, the lateral area we found in part C was 80, and we'd have to add the area of the base, and 8 times 8 is 64. So the total surface area is 144. Again, the total surface area is the lateral area plus the base information. Okay? 144. The volume we have on the page before is 1/3 the area of the base times the height. So the area of the base of a square base is 64. The height of the triangle we found is 3, not the triangle, the pyramid. So the answer is 64, because the 3's cancel here. Okay, so I'm gonna set you up for example 2, which is on this page, and if you turn the next page, there's all example 3. And I'd like you to finish these 2 pages all on pyramids before next class. But let's talk about this one. A regular hexagonal pyramid has a height of 8√3. A picture of its base is drawn below. Find the base area. Okay, it's a regular hexagonal pyramid, so we know that all these sides are 12, and this is just like the last unit where we have to find the central angle, and we have to find the information to get the area of the base here. So that gets you started. So you guys can find one triangle, multiply your answer by 6 to find the base area, and then you can use the, and go backwards and look to see all the, you can learn more about, or practice about volume, practice about slant height, lateral faces, lateral area. Look at the page before if you need any questions or have questions. Also, it's in 12-2 in your textbook if you want to refer back to those sections to also see the definitions in your textbook. So again, finish these 3 pages for homework, all on pyramids. See you next class.